Hi guys, this video is about the Arduinos and servos that I've used on various projects over the past few years. Here you can see the common Arduinos that I use, starting with the Arduino UNO, which can handle 16 pins of output. On some of the projects I've used a micro in one of two forms. This is the standard genuine micro, and on the side is the cheaper version you can buy from Amazon. You need to solder headers and pins onto this micro. On all your Arduinos, you need to know what the power input requirements are and what the power outputs are. Generally, Arduinos can handle about 400 milliamps out or about 40 milliamps per active pin. The Arduino Micro has more pins for input and output activity. One needs to know and take care of the differences between them. For example, the UNO will take 12 volts as an input, but the Micro won't take anything more than 9 volts. So you have to look at the specs in the datasheet and know the product you're working with. There are many other Arduino modules that could also be used, but these are the ones that I've worked. When you start out working with Arduinos, it is best to find a project that interests you, where you can copy exactly what the original author did. Sometimes the instructions are not good or not clear and can lead to frustration. My first project was to build a speedometer to measure scale train speed. I found this project, and the link shown here is still good, and found the instructions very readable, the project fairly simple. It uses two light-dependent resistors and has them spaced at a measured distance between each other. When the lock passes over the LDR, the change in resistance is measured by the Arduino. If it exceeds a 50% change in resistance, a timer is started and then stopped when the second resistor is triggered. The Arduino program then calculates and displays the scale speed in miles per hour or kilometers per hour. Now, after mastering that, I went on to build a Thomas train set for my grandson. On the Thomas train set, I installed 3 sets of railroad crossings. So that would be 6 servos to drive each arm up and down, and a set of flashing lights on both sides of each level crossing. Then I worked out a train detection and simple signal setting system using the knowledge I gained from the speedometer project. The whole thing worked out pretty well and was quite an interesting project. My first grandson, who is now 10, started with this setup, and the latest grandson, who's around 4, has the unit now. When he's done with it, we'll be salvaging the Arduinos and servos and moving on. Here is a short video showing what we're doing. The loco is going over one of these light-dependent resistors, and this triggers a reset of all 4 block light posts around the loop. So from green it goes to red to protect behind the loco, while the one in front turns green. Basically, it is a simple state machine, and each 3-color light signal's state is defined exactly by the LDR being tripped by the traveling loco. For the level crossings, I used a single switch to raise and lower all the gates at the same time. This also turns on the flashing lights at the crossings. Now let's look at some recent projects done in HO scale. As you listen to me discuss them, please remember that you can change the speed of any action and the timing and the sound. The fact that I've done it maybe slowly and you want to do it fast, feel free to understand that you can make any changes. One of the projects that I've done is what I call moving cows with Moo. And the idea was to try and get away from cows that just stand in the field and never move. The bits and pieces that you can see here are laser cut, and we're using the blue servo, about $5, to drive a spur gear. You can see in the center picture. The cow stands on the platform that is rotated. In the right-hand picture you can see where the driving gear meshes with the first cow, the 2 large gears mesh together, and you get opposing motion. You can make the motion faster, or for longer or larger angle of motion, just whatever takes your pleasure. So here we're seeing early tests where the scenery is not all finished. You can hear the cows moving in the background. And again, if the moves are not to your pleasure, it's pretty easy to edit the audio file and make a change. So here we've got the early morning sunshine on the scene, and in my glassworks factory you can see the furnace lights flashing of the glass furnaces. But let's focus on the cows and their movement. Here you can see the cows moving, and you'll notice the road in the top left hand corner is filled in over some of the holes you could see earlier in the layout. I've edited this video so that we see near continuous motion. Normally there's quite a delay between the motion actions. Here we can see that these two cows move very slightly. This is by design, just a small movement. But again, if you want larger movement, it's pretty easy to edit the program. Another project that I did with Zev is flying a kite, and here you can see an early version of the kite module. The servo is rocking back and forth to drive the kite. Now the box has been upgraded with a bit of scenery and 3 people watching the kite flying. This is the kite that Zev made with a beautiful tail on it, and this here is a shot of the kite flying on Zev's module. He has advanced his scenery quite a bit since this video, and he now has a kite flyer with his arm motioning off the wire. At a later date I decided to add another servo into the little box, and that's the result that we're looking at here, where I've added a barking dog that you can hear and will see in a moment. The servo makes him jump. And here's a little parking spot on the roadside near the rail for the kite flyers. Another project that I've done is my house lighting with fluorescent flash, and this is part of my little village, and you will see the lights in the central building go out in a moment. There is about a 15-minute sequence of lights slowly turning on and off somewhat randomly across the building. They turn on in the next building and will shortly turn on in this wood facade building. I leave the ground floor lights on permanently, as that is the level with the shops. Lights go on and off on both sides of the building. Let's look at the fluorescent flash. This is done by simply cycling the lights on and off. Here are the settings that I tested and discarded as not realistic. While here I've reduced the timing to make the flash faster, and you can see that the flash is much more pleasing. So that's just an indication of how you can find a better way to do it. I've got 2 points on my 2-rail trolley line that are controlled by servo, and here you can see just the arm of the servo sticking out the ground. It's connected to the actuator that slides back and forth to switch the point. I've had this running for about 4 years and it works like a charm. These servos are controlled by an ESU servo pilot. I recently added stop block detection to the trolley lines. The trolley lines have current sensed occupancy detection, but I wanted accurate stopping in the center here. So this is an additional signal that tells the computer when the trolley gets to the center of the passing lane. And likewise, this LDR detector tells me when the trolley arrives at the station. And this gives me an S88 input to my ESU central station. Please note that this S88 input is not a ground pickup as is normally done on a Markland layout. Another project that's not yet complete is my Zugbahnfuhrer. The idea here is to have a servo raise the guy's arm and another servo, which is on the bottom, to drive the man left and right. So you can set a time where the guy is just standing on the platform with his arm down. And then when a train starts to pull into the station, you can get the man to swing around and look down the platform at the arriving train, turn and look up the platform, or rotate whichever way pleases you. He can then turn to look at the driver and wave his flag to release the train. There are two servos here, and the top one is the one that raises the flag. The plan will be to raise the man's arm, and the wire to do this is running inside this brass tube. The brass tube is rotated by the lower servo, which is fixed to this frame and which would be bolted to the bottom of my train board. On the back side here we can see the electronics. I'm using an Arduino Micro with no headers just to keep a low profile. The two servos plug in down here, and at the top are the two bucks for power. So I have 12 volts coming into this setup via the wires, and a switch or relay that could be used to turn the unit on or off. Regarding the two bucks, the top one is supplying 5 volts straight to the servo, and the second one is supplying 7 volts to the Arduino. Unfortunately, this Arduino will not run on 5 volts. The Arduino has two output pins in use, a signal to the top servo and a signal on the green wire to the bottom servo. And that's where the programming comes in to make all the action. Looking at the costs, the bucks are between 50 and 75 cents a piece, and the Arduino is a pack of 3 for $15 to $20. Zev very kindly took my little man and put a pin in his arm, and I need to glue on this actuator and repaint him and so on. Then I'll attach him to the top of the unit and we'll test him out on the layout. One of the bigger Arduino projects that I did was my signaling system, where I believe I have saved a significant amount of money. This is the decoder as I mount it under the train board. You can see that this one is marked as decoder number 13, and in fact there are 12 of these units under my board. It is based on the Arduino UNO, and as I turn it up you can see the UNO at the bottom. The 12 volt supply goes in on these two pins, plus and minus, and the DCC signal goes in on these pins. Each Ethernet plug will give us two 3-color signal heads. So for example a home signal and a distant signal. We would then get 4 sets of home and distant signals out of this one decoder. The address ranges are engraved on here from 593 to 608, and at the bottom you can see 593 and 594 is the first pair of lights, and so on. Let's talk at a different level on this. Here we're looking at the circuit board that I designed and had built in China. On this board I get 16 outputs from my UNO, and I need 8 times 3 colors or 24 output pins, and I've got overcome the deficiency in number of pins by using logic chips over here. The logic chips give me the extra pins, and the way it works is that I turn the green light on and off or the yellow light on and off, and when both the green light and yellow lights are off, The logic chip says that's the time to output a signal for the red light. This little area in the board down at the bottom is where the DCC signal goes in, and these chips is where the DC signal is opto-isolated from the high voltage 16 to 17 volts side of the track power down to the 5 volt side, and it comes in around here on pin 2 for the UNO. There are no headers on this board yet, but the rest of the board is finished and this project has been quite successful. Hi guys. The ideas behind this project came from Ross's very impressive installation of fiber optics in his Volmer signal box project. The model selected was a result of the presentation to the ETE group by David Sampson. As I neared completion of the first model, I decided to order and build 2 more to cover all.